Welcome back to JVM Internals Crashcasts. I'm your host Sheila, and today we're diving deep into the world of JVM security. Specifically, we'll be exploring sandboxing and isolation techniques. Victor, our JVM expert, is here to guide us through this fascinating topic. Before we begin, listeners, here's a quick quiz for you. True or false? JVM sandboxing completely prevents all types of security vulnerabilities. Think about it, and we'll reveal the answer at the end of the episode. Victor, what do you think about this question?
That's an intriguing question, Sheila. It touches on a common misconception about security measures. Without giving away the answer, I think it's a great way to get our listeners thinking critically about the capabilities and limitations of sandboxing techniques. I'm excited to explore this topic in depth and see how our listeners' perspectives might change by the end of the episode.
Absolutely, Victor. Let's start with the basics. Can you explain what sandboxing and isolation mean in the context of JVM security?
Certainly, Sheila. In the JVM context, sandboxing and isolation refer to techniques used to run untrusted code in a controlled environment. Think of it like a playground sandbox where kids can play safely without affecting the surrounding area. Similarly, JVM sandboxing allows potentially risky code to execute without endangering the rest of the system or accessing sensitive resources.
That's a helpful analogy, Victor. So why is sandboxing important for JVM security?
Great question. Sandboxing is crucial because it allows the JVM to run code from various sources while maintaining a high level of security. This is particularly important when running applets, downloaded code, or third-party libraries. By isolating untrusted code, we can prevent it from accessing sensitive system resources, modifying critical data, or performing malicious actions.
I see. So, how does the JVM actually implement sandboxing and isolation?
The JVM uses several mechanisms to implement sandboxing and isolation. The primary tool is the Security Manager, which enforces security policies. Another crucial component is the ClassLoader, which can provide isolation between different parts of an application. The Java security policy allows fine-grained control over what actions code is allowed to perform.
That's interesting. Can you elaborate on how the Security Manager works?
Certainly. The Security Manager acts as a gatekeeper, checking whether code has permission to perform specific actions, like reading or writing files, opening network connections, or accessing system properties. When a potentially dangerous operation is attempted, the Security Manager consults the security policy to determine if it should be allowed or blocked.
I think I understand. So, if I have a piece of code that tries to read a sensitive file, the Security Manager would step in and potentially block that action.
Exactly, Sheila. That's a perfect example. The Security Manager would check if the code has the necessary permissions to read that file. If not, it would throw a security exception, preventing the unauthorized access.
Got it. Now, you mentioned ClassLoaders earlier. How do they contribute to isolation?
ClassLoaders play a crucial role in isolation by creating separate namespaces for classes. This means that classes loaded by different class loaders are isolated from each other, even if they have the same name. This technique is often used in application servers to isolate different applications running in the same JVM.
That's fascinating. It sounds like sandboxing and isolation techniques have come a long way. Are there any recent advancements or trends in this area?
Absolutely, Sheila. One significant trend is the use of container-based isolation, popularized by technologies like Docker. While not strictly a JVM feature, many Java applications now run in containers, providing an additional layer of isolation at the operating system level. Additionally, projects like Project Jigsaw, introduced in Java 9, have enhanced modularity and security by allowing better control over which parts of an application can access specific modules.
That's really interesting, Victor. It seems like JVM security is constantly evolving. Can you share a real-world example where sandboxing prevented a security breach?
Certainly. There was a case a few years ago where a large financial institution discovered a potential vulnerability in a third-party library they were using. Thanks to their robust sandboxing setup, the compromised library was unable to access sensitive customer data or make unauthorized network connections. This prevented what could have been a major data breach, giving the institution time to update the library and address the vulnerability.
Wow, that really highlights the importance of proper sandboxing. Now, as we're nearing the end of our episode, let's circle back to our quiz question. Victor, would you like to reveal the answer?
Of course, Sheila. The statement JVM sandboxing completely prevents all types of security vulnerabilities is false. While sandboxing is a powerful security technique, it's not a silver bullet. It can significantly reduce risks, but other security measures like proper input validation, secure coding practices, and regular updates are also crucial for comprehensive security.
Thank you, Victor. That's an important point for our listeners to remember. To wrap up today's episode, let's summarize what we've learned. 1. Sandboxing and isolation in JVM allow untrusted code to run safely. 2. The Security Manager, ClassLoaders, and Java Security Policy are key components of JVM sandboxing. 3. Modern trends include container-based isolation and enhanced modularity. 4. While powerful, sandboxing is just one part of a comprehensive security strategy. In our next episode, we'll be exploring alternative JVM implementations, starting with OpenJ9. Don't forget to subscribe to JVM Internals Crashcasts and leave us a rating if you enjoyed this episode. Until next time, keep diving deep into the JVM.